Hey everybody, in this video I'm going to walk you through one method for comparing the atomic radii of two or more atoms, and we're going to do it for chlorine versus bromine. The whole process starts off by looking at the electron configurations of the atoms you're trying to compare. So here we've got those done for both chlorine and bromine. I'll add that this is probably the most important step, and a lot of people try to skip this and just think about what these atoms look like, and I think it just makes the whole thing so much harder. So really force yourself to write out these electron configurations first. Once you've got that, the next thing we want to notice about each atom is the outermost electron energy level. Exactly what energy level do each of these atoms fill up to? In chlorine's case, we can see from the configuration their outer electrons are in the 3s2 and the 3p5. In other words, the third energy level. And for bromine, there's a huge difference there. Its outermost electrons go to the fourth. The next thing we want to analyze is how much shielding each of these atoms have, or how many shielding electrons they each have. Sometimes these are referred to as the core electrons. Sometimes these are referred to as the inner electrons. They're pretty much everything else except the valence. And here on the configurations that I have written out, the outermost, in chlorine's case, the 3s2 and the 3p5, those are the valence. So the inner electrons, the shielding ones, are all of the electrons represented here with the neon symbol. And that neon symbol represents 10 electrons, which means chlorine has 10 shielding electrons. In the case of bromine, it has 7 valence electrons in the fourth energy level, the 4s2 and the 4p5. That means everything else except those would count as inner core shielding electrons. That includes the 18 electrons of argon, plus I'll even add in these 10 electrons in the 3ds. So we'll consider that 28. Now that's a bit of an oversimplification, but for our purposes here today, it's the best way to go about this. So bromine has a lot more shielding electrons. The next thing we need to know is the comparison in nuclear charge between these two atoms. That's pretty simply found by just looking up the number of protons that each atom has. Chlorine, of course, has 17 protons. That means its nucleus has a charge of plus 17. Bromine has 35 protons. That means its nucleus has a charge of plus 35. I'll point out that so far there's a lot of differences between these two atoms, right? Their outermost energy level's different. They have different shielding electrons. They have different nuclear charges. A lot of this starts to come together now when we do the effective nuclear charge. And while again this is going to be an oversimplification, it's a good method to come up with an approximate value for this effective nuclear charge. All you've got to do is take the original nuclear charge and subtract out however many shielding electrons there are. Here I'll just represent that with these symbols. In chlorine's case, that's the plus 17 nuclear charge minus those 10 shielding electrons to find out that chlorine has a plus 7 effective nuclear charge. If we do the same thing for bromine, remember, it has a plus 35 nucleus minus its 28 shielding electrons. Bromine has a plus 7 effective nuclear charge also. And now we're at the final stage to make the analysis we have to make in comparing the sizes or the radii of these two atoms. It's all about two factors from this table. And I'm going to circle them in green so everybody's super clear on exactly what you need to consider. The outermost energy level of each atom versus the effective nuclear charge. Those are like the two things that you need to consider when comparing these atoms. And when you do that, you can see straight away that while there's a lot of data in this table, all of it leads to two facts. One of them is the fact that chlorine and bromine have essentially the exact same effective nuclear charge. Plus 7 for chlorine, plus 7 for bromine. This is good news because it means I don't have to worry about effective nuclear charge. There is no difference between chlorine and bromine. That means the only real difference is the outermost energy level. The fact that chlorine only has electrons in the third energy level, while bromine has electrons in the fourth, is the key difference in explaining their size. Essentially, what this tells me is that the outermost electrons in bromine are farther away. The fourth energy level is bigger. Those outermost electrons have a weaker attraction to the nucleus because they are farther away in that fourth energy level. We could say the same thing here for the outermost electrons in chlorine. Because they're closer to the nucleus, they're going to have a stronger attraction to it. Of course, anytime there's a stronger attraction between the electrons in the nucleus, that's going to pull the electrons closer to the nucleus, making it smaller. That means bromine with a weaker, and its electrons with a weaker attraction to the nucleus, that's going to allow bromine to be larger. And if you follow this type of a format, any single time you're making an atomic radius comparison, you're likely to come up with the answer. Thanks a lot for watching.